All right, everybody. So with this video, I wanted to have a page that was an overview of everything that we would learn in the video. And what I want to do was go through each thing that you see here. And then what I'm hoping that you'll be able to do is quiz yourself at the end of the video, okay? And I'd say this because this is the way I learned when I was in college. I would read a book or I would listen to what the teacher had to say in class. And then, I would try to take that all in as best I could. I would try to get blank paper out and just write down as much as I could remember based on what I had just seen. Okay. And I found that as I did that, I took in the information better when I was listening, and I remembered it better when I wrote it down. Okay, and it took some practice, and if I'd forget some things, so I'd go look things back up and fill in the gaps, and then I would try it again. I would always try to do what I could from memory with blank paper, and that really seemed to help me a lot. And I guess everybody's got to find their own way and find what works for them, but I think at least at the end of the video, you can quiz yourself about what all this stuff is and see if you remembered it, and maybe you could think of an example of each concept, okay? Anyway, so let's start. So, all right, our topic. So, dependent events and independent events. Okay. So, an event is something that happens in a probability experiment. And a probability experiment is something with an uncertain or random outcome, such as flipping a coin or something like that. We don't know how it's going to work out. Or picking a card, drawing a card randomly from a deck. I don't know how that's going to work out either. Okay. So something like that, survey questions, asking people their opinion, who knows? Okay. Now, among events in general, there are dependent and independent events. And then there's a related concept called conditional probability. And so I hope that you could give the definition of each of these and maybe an example to go along with it. That's what I would want to do if I was learning it. Okay. And then maybe explain a little bit about the connection between all three of them. All right. So the stat cat says, try to quiz yourself. Yeah, I think that's important. Just see what you retained, and then you can watch it again or think about it again or read the book or whatever, whatever works for you. Okay. So let's start with dependent versus independent events. Okay. So, I'll just tell you what they are, give the definition, and then give an example to go along with it. All right. So, dependent events are events where one event happening does influence the probability or likelihood of the other event happening. Okay. All right. One event happening does influence the probability of the other event. Now, we use this all the time, okay, in everyday life. We could say, now I say this, I don't know the odds of this particular thing, but let's say, what are the odds that somebody gets lung cancer versus what are the odds that somebody gets lung cancer if they've smoked for 40 years, okay? So those are two different things, right? If you know somebody smoked for 40 years, then doesn't that alter, I don't know how, I don't know what the numbers are, it's off the top of my head, but doesn't that affect the odds of them getting lung cancer? Yeah, I think it does. That seems to be what we're told all the time. And my point is that, we are familiar with what dependent events are, whether you knew about it at the beginning of the video or not. Okay, so here's an example that is sort of like, when we're learning things in class and so on, and you're given examples to understand. This one's kind of like an example that you might come across in homework or something like that. So suppose that we select a citizen at random from the United States, okay? And one event is that the citizen happens to live in Texas, and another event is that the citizen lives in Austin. Now, if you just selected a U.S. citizen at random, there's a certain likelihood that that person lives in Austin. But suppose that you select a citizen at random and you know that they live in Texas. Does that make them living in Austin a little more likely than otherwise, right? So yeah, if I just select a citizen at random, there's a certain likelihood that they live in Austin. But if I select a citizen at random and they live in Texas, then that makes them living in Austin a little more likely than otherwise. Yeah, so this event makes that event more likely. These are dependent events, okay, for that reason. All right, now let's talk about independent events. So, well, that's just the opposite of dependent events. Independent events are the opposite. One event does not influence the probability of the other event. Okay, so here's the example that I'll give you for independent events. So suppose you have a deck of cards. All right, that's an example that we've used before, right? So I've got a deck of cards right here, okay. And we're going to select a card at random from the standard 52 card deck, okay? We're going to replace the card, then we're going to shuffle. And suppose that event A is that you select the Ace of Hearts, that's this card, on the first draw. And B is you select Ace of Hearts on the second draw. Does event A, suppose I do this, I got the decks all mixed up, and I take a card at random, and it's the Ace of Hearts, okay. And then I put it back, and I shuffle it, so on. And then because I selected Ace of Hearts on the first draw, does that make it more unlikely that I select it again on the second draw? Or does it make it more likely that I select it again on the second draw? Okay. No, I mean, if I'm putting the card back and I'm shuffling it, then it doesn't matter. It doesn't matter that I selected it on the first draw. Maybe it makes it seem more unlikely that I would select it again, but the odds of selecting it again, I mean, I'm basically taking it out of the same deck. It's mixed up the same way. It's shuffled. I put the card back. So these are independent events. The fact that that one happened does not affect the likelihood that this other one happens. Okay? All right. The probability is in fact 1 out of 52 in each case. This Ace of Hearts is just one of 52 cards I could choose. All right, so that's an example of independent events, okay? Do you see how this one does not change the likelihood of that one at all, okay? All right, now let's do, since we're talking about this, we can change this. Sometimes when you're learning this and you're trying to be, see examples to gauge your understanding of the concepts. What if the example is a little bit different? Here's another example that you might see where we don't replace the card, okay? So suppose I select Ace of Hearts on the first draw. Just like luck of the draw, I select Ace of Hearts. But say I don't replace it. Then does that change or alter the odds that I select Ace of Hearts on the second draw? Well, yeah. What are the odds that I select Ace of Hearts on the second draw? 0. This is not in there anymore, okay? So yeah, if I don't replace the card, that would make these dependent, okay? But the fact that I replace the card and I shuffle it and I'm basically choosing from the same deck that I started with, then, it's totally independent, okay? All right, now let's go to the next topic. Okay, so let's see, what are we going to do? Dependent and independent events. All right, check. Got those, right? We did an example of each one. Then the next one is conditional probability. So this is another concept we use in everyday life, whether you know it or not. And it's closely related to the topic of independent and dependent events, okay? But so first of all, let me tell you what it is, and then we'll talk about the notation and symbols that go along with it. So conditional probability is the probability of an event occurring given that another event has already happened. Well, it sounds kind of like what we're talking about. That sounds like it might involve dependent events. Remember, what are dependent events? It's when one event happening affects the likelihood of some other event happening. Okay? So our notation for it is we do P for probability, parentheses, B vertical line A, close parentheses. And that means the probability of B happening given that A has already occurred. Okay? The probability of this event happening given that that one has already happened. So it's this one is the already. Already happened. Okay? What are the odds of this one given that that one has already happened? Okay. Let's see an example of that. And here I got this from the My Math Lab assignment, actually. Okay, so we're given some data and then a probability experiment. So the data is like, okay, well, we have this school and they ran some numbers on the male versus the female students getting either business degrees or some other kind of degree that's not business. Okay. So those are numbers like, and so it says like, well, there were, for example, 163,024 female students who got business degrees. And then there were 918,266 female students that got some other degree besides business. All right. Okay. So we're going to select a student at random. That's the probability experiment. This is the data. And I have my events that I want to talk about here. A is that the student that's selected at random happens to be male. Event B is that the student selected at random happens to have received a business degree. And event C is that the student selected at random happens to be female. Okay. So what's the probability of event A, that you randomly select a student, okay, at random, and that student is male? All right. So, oh, sorry, hold on. All right. Right as I was about to explain that, I noticed a miscalculation. Anyway, okay, so, and I fixed it. So if you were curious about this initial number, all right, I changed that, and I'll tell you why. So the probability that you select a student at random and that student is male, okay, well, what's our basic definition of probability? The number of ways that that event can happen divided by the total number of outcomes. So that would be the probability that a selected student at random is male is the total number of male students over the total number of students. All right. So I see that there are, 184, 319 plus 603, 417 male students over 184, 319, 603, 417. And I have to add all types of students together, okay, because there's no overlap between any of these categories. So that'd be the male students over the total number of students. And then that turns out to be 0.421, or about 42.1%. Okay, so if you select a student at random, you've got about a 42.1% chance that student just happens to be male. Okay, so from there, what about this conditional probability? Because that's what I wanted to show you with this slide, is how do you think about the probability of one event occurring given that some other event has already happened, okay? So how would you read this? This would be the probability that a student is male given that the student you selected has received a business degree. So it's like this. Suppose that you select a student at random, and you know that they received a business degree. That's what this says. So you know that much. So you selected that student at random, and I say, well, this student received a business degree. Can you tell me what the odds are that they're male on top of that. So not just the probability that they're male altogether, but the probability that they're a male student, given that you know that they have a business degree. Okay. So, all right. Well, look, among the business degrees, there are 184, 319 males, and there are 184, 319 plus 163, 024 total students. So again, among the business degree students, here's the number of them that are male, and then on the bottom is the total number of students. That decimal works out to be about 0.531, or you have about a 53.1% chance. So that's a conditional probability, all right? Okay, so you see the difference between those, right? The probability of event A is not the same thing than the probability of event A, given that you know that B already happened, all right? It changes how you do the calculations. Let's do one more. Let's see, the probability of B, given that C already happened. Well, C is that the student is female, and B is that the student received a business degree. Okay, so this is asking, what are the odds that a given randomly selected student received a business degree if you know that they're female? See, in that case, I guess you're just looking at this, right? All right. Okay, because I want to know, like, I selected a student at random, and it turns out I know they're female. So they're either here or here. Okay, they either earned a business degree or they earned some other kind of degree as a female student. Okay, so what are the odds then, if I selected a female student at random, that they would have earned a business degree? Okay, well, of the female students, 163,024 earned a business degree out of a total of this number plus this number. So look, I did 163,024 over 163,024 plus 918,266. Okay, so that's the female students over the total number of female students. The female students that earned a business degree over the total number of female students. Okay, that would be this conditional probability. The odds that a randomly selected student received a business degree, given that you know they're female. All right, so hopefully, between this and this and this, we see how calculating a probability is different than calculating a conditional probability. All right, so we'll see some other examples too, but let's do this. Let's talk about the connection between all three concepts, because we did dependent events, we did independent events, we did conditional probability just now, and then what's the connection between all three? It seems like there would be a connection, okay? Because here, dependent versus independent events is whether or not one event happening affects another happening, and conditional probability is what's the odds of one thing happening given that another thing is happening. All right, so yeah, we're up to the connection. So the stat cat wants to ask, what's the connection between all three of these things, conditional probability and independent events? So here goes the connection. See if you can think of what it is before we get there. So suppose that A and B are independent events. Now, what's that mean? It means if one of these happens, it doesn't influence the likelihood that the other happens. That's what independent events are. So what is the probability of A happening given that B has already happened? If they're independent. Or vice versa. Like now, if they're independent, they don't affect each other either way. If one happens, it doesn't change the likelihood that the other happens either way. That's what independent events are. All right. Okay, so what do you think then? What's the probability of A happening given that B has already happened or vice versa? Well, the probability of, if they're independent, A happening given that B has already happened is just the probability that A happens. Why is that? Well, because if they're independent, B happening doesn't affect the likelihood that A happens. And then what's the probability of B happening given that A has already happened? Well, it's just the probability of B happening at all. Okay? That's just what independents are by definition. Independent events, I mean, you could say just mathematically means this if you were to write an equation instead of give a definition with the words. Okay. All right. So let's do this. Let's see like maybe 2 more examples of conditional probability and independent and dependent events. Okay. So let's say we select a card from a deck and we replace it and we shuffle. A standard 52 card deck. Okay. All right. So we're already kind of familiar with that. You know, I've talked about the deck of cards before because it's something that's at least a little bit familiar with everybody. So it shouldn't be too bizarre. Maybe you have a deck of cards at home and you could look at it if it helped you think about what we're doing. So let's say we have these events. The first draw is any queen, and then the second draw is also any queen. Now, first of all, what kind of events are these? Do these affect each other? Does one make the other more or less likely? These events are definitely independent. If you replace the card you draw and you shuffle it, then you're starting over when you draw that second card. So that's why they're independent. The first draw does not have anything to do with the second draw. Okay? All right. And maybe if you have some magician shuffling the cards and doing some sleight of hand, maybe then it does, but let's say that that's not happening and it's just you're just shuffling it as you put it back. So, all right, let's see. What's this mean right here? Remember, you got to learn how to read the notation. The probability that the second draw is a queen, any queen, given that the first draw was any queen. Okay? So think about that a little bit and see, like among queens, we have 4 of them, the queen of diamonds, the queen of hearts, somewhere in here is the queen of spades, and the queen of clubs. All right, so that means there's 4 total. Okay, so there's the queen of spades. There's also queen. I only found 3 of them when I was thumbing. Oh, there we go. So there's 4 queens, right? There they are right there. So if you chose a queen on the first draw, by chance, you replaced it, you shuffle them around, and you're starting over by the second draw. So the odds that you choose a queen on the second draw, given that you chose a queen on the first draw. Well, in that deck, as you're sitting there on your second draw, there are 4 queens sitting in that deck, and there's 52 cards total. So it's 4 out of 52. So yes, it's just the odds of drawing a queen at all. Okay, you could think of it like that. Doesn't matter if it's the first draw or the second draw or whatever. The odds of drawing a queen on any draw is independent of any other draw. And it's just equal to the odds of drawing a queen at all. Okay, so those events are independent. And to calculate then the conditional probability is just to calculate the probability of drawing a queen anytime. All right. Okay, so, well, that's what it would look like if you selected a card from a deck and replaced it. All right, so let's see an example that's kind of like that, but is just enough different to change all of our calculations. Okay, so suppose we select a card at random from a deck and we don't replace it. All right, okay. So here, I want to talk about the same 2 events. The first draw is any queen. So it could be any of these, right? Queen of hearts, queen of diamonds, queen of spades, queen of clubs, okay? And then the second draw is any queen. Now, these are not independent. If I do not replace the card I took out, then that is going to change the odds of drawing another queen, okay? So here's how. So what's this one say? This one says, what are the odds of the second draw being a queen, given that the first draw was already a queen? Well, think about it. So if the first draw was any queen, say it was this one. All right, and you drew that one and you took it out. You didn't put it back in. This is what's left on that second draw. So what's left on that second draw is 51 cards because we took this one out, and only 3 queens because we took this one out. All right. So here with these dependent events, in this case, the odds are 3 out of 51. All right. Okay, all because we didn't replace the card. Now, let's do one. I mean, these are, with them both being queens, maybe it's obvious that they're connected, that they're dependent if you're not replacing. What about like a card that's unrelated to a queen and different? Like what if the first draw is a 7, okay? All right, so, that's not a queen. Does that somehow influence the second draw being a queen? So let's say this. Let's do this one now. What are the odds that the second draw is a queen, given that the first draw was a 7? Okay, well, a 7 and a queen are different, but still, those are dependent events. Here's why. Yes, the fact that the first draw is a 7, that's already happened. And the fact that in our probability experiment, we're not replacing the card that we draw. All right? Then here's what we're doing. By the time the second draw comes around, there are 51 cards left. Say I drew this one, and I took this and I put it away and I didn't replace it. This is what's left. 51 cards are left, but there's 4 queens left because I didn't draw a queen the first time. All right? So then it's 4 out of 51. So even if the first card was a 7 and then I want to talk about the next draw being a queen, if I'm not replacing it, it does alter the odds on that second draw, but in a different way than if I'm, say, drawing 2 queens in a row. Okay, so that's conditional probability. Those are dependent and independent events. All right, so I was hoping by the end of the video we could do, kind of mentally run through all these. Maybe you got some blank paper out and you can write them all down, see how much you remember. Dependent events do influence each other. If one occurs, that does make the other more or less likely the other one occurs. Independent events, if one occurs, then that does not affect the likelihood that the other occurs. Conditional probability is tied right into this because this is when we do the calculations here. In conditional probability, we're calculating the odds of one thing happening given that another thing has already happened. And then that's the connection between all 3 of them, is that the probability of one event happening given that another event has already happened is just the probability of this event happening at all. Probability of A happening given that B is already happening or happened is just the probability that A happens at all. What's that? If they're independent, right? Isn't that what independent events are? What did we say? Independent events are events where one does not affect the likelihood of the other. So, if you know one has happened, the probability of the other happening is just the probability of the other happening as it is.